Okay, so 4.1 video lesson, writing equations from graphs. Let's read these directions and then I'm going to remind you a little bit about sine and cosine graphs. It says, given each graph, write two equations, one in terms of sine and the other in terms of cosine. You will need to look closely at the x-axis to determine if the x values are in terms of degrees or radians. Sometimes it's obvious, like in this case, because we have a theta and you can see the degree mark. On other ones, it's not obvious. Maybe if you see a pi, you know you're in radians, but I'll just kind of help you see on each problem whether you can determine whether you're in degrees or radians. It won't be given to you. It won't say the word degrees or radians, though. From now on, that's something you'll have to figure out. Okay, another thing is, when we're dealing with sine or cosine graphs, remember that we had this main equation, y equals c plus a. And then you could either write sine or cosine, b, and then parentheses, this could be theta, it could be x minus d. Okay, so let's just kind of go back through what everything was. C is your shift up or down. It's your vertical shift. Up if it's positive, down if it's negative. A is your amplitude. That's the distance from the sinusoidal axis to the peak or to the low point. B is not the period, it's actually the frequency, but you use B to find the period. And then here we have theta minus d. This is your horizontal shift. So if it's theta minus a number, then that would be a shift to the right. If it's theta plus a number, that would be a shift to the left. And that's how we graphed sinusoids. And when I say sinusoid, I mean a sine curve or a cosine curve. Any periodic graph like these waves. And so we're going backwards basically, and at first it's kind of weird, but soon you'll find that this is much easier than actually graphing. Okay, so we need to do a sine and a cosine. Let's start with the sine one. Okay, so first we need to figure out what is the shift up or down. Okay, so in this particular case, we're going to go ahead and write everything out. This is down 5, so my first number here would be negative 5. Okay. We did have vertical reflections on these. It's just always easier to assume that you don't have a vertical reflection. So we're not going to make anything harder than it really needs to be. The next thing we need to figure out is what is the amplitude. Okay, this is your A value. So our amplitude from negative 5 either down to negative 12 or negative 5 up to 2. That's 7, a distance of 7. So our amplitude is 7. So we're going to put a 7 right there. Like I said, we're going to do the sine curve first. Okay, next we need to figure out what the period is, and this is what catches most students. Probably the easiest way to do period would be to go from any peak to another peak or low point to another low point. It doesn't matter, but you want to make sure you have a complete cycle. Okay, so from 8 to 20, that is a distance of 12 degrees. Okay, so if our period is 12 degrees, remember that the way we found the period was we did either 2 pi, or in this case, since we're in degrees, 360 divided by b. Okay, so if I did 360 divided by b and I would have come up with 12, you are going to find b this way. Now let me just tell you though, because this is in basically of the relationship between the period and b, you can find b the same way you used to find the period. So I'm going to do 360 divided by 12. So I'll kind of explain it more on this one, and then from now on we'll just do things the easier way. So imagine if up here you were trying to find b. You could cross multiply, and so that would give you 12b equals 360, and then you would divide by 12. That's why it works out that way. Okay, so 360 divided by 12 is 3. Or I'm sorry, is 30. So that is your B value. Now notice I'm not doing anything about dividing by 4. That would be with critical points. That's usually not useful in this, because even on this, not every critical point, like this middle one, for instance, and here, they're not even listed. So in another problem where all you know is the critical points, you might want to do that. In most problems, though, you're going to go peak to peak or low point to low point or any way to come up with a cycle. Then you're going to do 360 or 2 pi divided by that number. That's going to give you your B value. And you can always check your work by going with what you know best, which is how to graph sine and cosine. So from this 30, do you get this graph? And that's how you can check your work. Okay, the last thing, I am going to put a theta here because that's what they have marked on the graph, and we're in degrees, and typically when you see theta, you're going to be in degrees. And this is where you have a choice. Now you've got to remember though that we're dealing with sine here. So I need to use a point like this, or a point like this, or I could even use this point over here. But you can't just pick any middle point. Like let's say for instance I wanted to pick this one. That would be kind of ridiculous because then I would have to put a vertical reflection in. That makes the problem harder than it needs to be, so don't do that. And none of these are listed anyway, so we're going to have to actually find out what this would be a shift to the right, or in this case it'd be a shift to the left. I'm going to do this one, it looks a little bit easier. So what is the number exactly in the middle of 2 and 8? That's how I would approach this. That's the easiest way. Or what is the average of 2 and 8? And that number would be 5. So this graph is being moved to the right 5. So I'm going to put minus 5 degrees right there. And that is one option for sine. There are infinitely many. The only thing though that would change would be this horizontal shift right here. So you could have gone to the left. Look at it looks like this would be -7, so that would be theta plus 7. That's an option, but keep things easy on yourself. Don't come up with the hardest equation possible. Come up with the easiest one. That way you'll be ensure that you're right. Okay, let's do a cosine one. Now everything here is going to stay the same, except I'm obviously going to write the word cosine, and my horizontal shift will change. That's the only thing, because dealing with sine and cosine, that's the only difference between the two. They're just a horizontal shift apart. Okay, and in this problem, cosine is actually easier because where these peaks are already listed. So I could do a shift to the right 8, or I could do a shift to the left 4. Let's go ahead and do to the left. And so that would be plus 4 degrees. But like I said, I could have put minus 8 here, could have put minus 20. Okay, it doesn't matter. But here we have a sine curve and a cosine curve. Okay, let's look at the next problem. Problem 2. Okay, so it does not say whether I'm dealing with radians or degrees. So you got to think, what makes sense here? I see x, that's my first clue, but I also see pi, and I don't see anything with degrees, so I'm assuming that this is a radians problem. That's a safe assumption. Okay, so let's look at what's happening here. It looks like we're moving up 5 with an amplitude of 2, so let's go ahead and start. That would be 5 plus 2, and let's do the sine first. So the next number would be b. Alright, like I said, this is really the only real work you're going to have to do on these problems. It's going to take some time. Let's look at from peak to peak. That's going to give us the period. So 1 pi over 6 to 7 pi over 6, what is that distance? Okay, you could subtract the two values. You could just think, what do I need to add to pi over 6 to get to 7 pi over 6? And in this case, it is pi. All right, so our b value is going to be 2 pi over the period, which is pi. And so our b value in this case is 2. All right, parentheses. The x-axis is labeled with an actual x because we're in radians, so I'm going to go ahead and write that. And to do sine, I either need to go to right here or to right here. Okay, now again, I don't have the tick mark associated with this. So I need to figure out what this tick mark is or this tick mark. It doesn't really matter. I would pick whichever one you think is easier to work with. So let's look at this one. Since both of these are positive, it'll probably be easier to figure out what is the number in between them, or what is the average. If I change this to 4 pi over 6, that might make things a little bit easier. What would be right in between 4 pi over 6 and 7 pi over 6? And it's still somewhat confusing because it's not, if this were maybe 6 pi over 6 or something, we could figure out what was in between exactly, but it looks like I'm dealing with 5.5 pi over 6. So maybe I need to go to another common denominator, and I'm going to actually switch up colors here just to make this really clear. I'm going to change this one now to over 12, okay? So what would this tick mark be over 12? All right, it was 4 pi over 6, so that would be 8 pi over 12. And this one over 12 would be 14 pi over 12. So all I'm doing really is figuring out what is the value in between here. I can average these two just by adding and dividing by 2, or I can think logically, which I think is going to be easier for most of you. What is the value between 8 pi over 12 and 14 pi over 12? Right, it would be 11 pi over 12. That's that tick mark right there. And I would do something very similar if I wanted to go to the left. And this is just, if you're having a hard time understanding this, it's mostly because you probably aren't that strong with fractions, and we're just going to keep dealing with fractions. Don't make things harder on yourself, though, by doing a lot of computations. If you can just think logically about the numbers, it's a little bit easier. So since this is to the right, I'm going to do minus 11 pi over 12. And now let's do our cosine equation. So almost the exact same, except we would write cosine. And I have a different shift. And again, this one is much easier because I can see a peak right there. And that's to the right pi over 6. I notice that when I'm grading these, sometimes students will pick this low point right here. And that's fine. You can pick that. But then you have to take into account that you're vertically reflecting the graph because it's a low point instead of a high point. So you'd have to change this to 5 minus 2, and that's perfectly acceptable. If you wrote that down, you would be right. It's just, why make things harder on yourself if you don't have to? Okay, now let's get to problem number 3. And if you notice, so far all of these look like they came from different computer programs, and they did. Most of these are cut and paste from old textbooks or calculating software because just from materials that we had, and we wanted to give you a wide variety of what these graphs could look like. Okay, this problem is weird for a couple of different reasons. Okay, first off, the y-axis we know has to be y, but the x-axis is not labeled with an x or a theta, and I don't see on these tick marks degrees or anything indicating radians. When you don't see degrees, though, it is implied that you are dealing with radians. You will see an actual degree symbol. You'll see a theta if I want you to be in degrees. So we're going to assume this is radians. Okay, so if we look at this, you might look at the 5 and say, oh, that's the sinusoidal axis. But you need to be careful here. First off, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the top tick mark. Let's label that. And then the low tick mark, it's a little hard to tell, but it's right here at -1. Okay, so it looks like there's a span or a range of 10 units here. And so that would not make the sinusoidal axis at 5. It would actually make it here at 4. Okay, so because this one's a little weird, let's write this down. This is going to be a shift of up 4, and the amplitude is going to be 5 in this case. I would think on this problem in particular, a lot of students would get these two numbers mixed up. They'd think, oh, 5 is the middle, up 4, and just by not looking at it closely enough. Okay. Let's go ahead and find the b value next, because before we start writing it down. Again, you could go from peak to peak. Okay, so if I start at this peak, it looks like that's at 1. Okay, so 1 right here. And if I go all the way to this peak, you kind of have to look at this pretty carefully. So it looks like 11, 12, 13. Okay, sorry. 11, 12, 13. Alright, so if I went from 1 to 13, that is a period of 12. So if the period is 12, then the b value, remember we're in radians, would be 2 pi over 12, which would be pi over 6. Okay, so let's go ahead and start writing our equations, and then that last part, the horizontal shift, we'll have to, again, also figure out for sine and for cosine. Okay, so up 4 means we start with 4 plus 5, and then sine of pi over 6, parenthesis, x. All right, and let's go ahead and write it for cosine as well. Let's just go ahead and get down on paper what we know. And I really, again, want to emphasize that the equations for sine and cosine are the same except for this horizontal shift. Okay, the cosine one is obviously easier. If you haven't picked up on that, it's going to be easier on almost every problem. So let's look at the first peak. That was to the right 1. So I'm going to go ahead and do this one first. And again, I'm going to have to, and this is going to be a pain on some of these problems, I'm going to have to figure out where is, you know, the starting value. I don't want to pick this one. I almost did on accident. Where is the left or right shift for sine? Okay, so it might not be obvious. This is one place where critical points might actually help. So let's go ahead and do that on this one. Because I don't have two, you know, before I had a low point and a high point, and those were clearly marked, and all I had to do is find what the value was in between. And now this looks like 10, but it could be a little misleading. We know when we write on a graph it might get off a little bit. So this is one case again where I think critical points might help. So if the period is 10, how far apart would the critical points be? I'm sorry, if the period is 12. All right. You know, if we had been graphing this, we would have divided by 4 and found out that the critical points are all 3 apart. So I could subtract 3 from the 1. That would be right here at -2. Or I could subtract 3 from 13, and I would end up at 10, which is marked there. So either one of those would work. Just to kind of switch, we haven't done a lot of these over here to the left, so I'm going to go ahead and put +2. But I definitely could have put -10. In the end, it would give you the same graph. You have options right here. It doesn't mean that everything's right, but it means that you're always going to have more than one choice. Okay, let's look at the last two. Number 4, it doesn't look like there's a lot plotted, but I do see a pi and an x, so I'm going to go ahead and write up here that we're in radian mode. Okay, so at least the sinusoidal axis is marked clearly, so that's going to give me the first number, and also I can see clearly that this is going to be a shift up, or I'm sorry, from the middle it's up 9 or down 9, so I'm going to go ahead and write +9. Alright, the next thing. Okay, well, I can see not these tick marks right here. It would be helpful if I were given these tick marks right here, but I'm not. Okay, I'm just given the 4th one, and let's see if you can see there's 1, 2, 3, 4 cycles that gets me to pi. Okay, so probably what most of you would be thinking right now is, oh, well, just divide this up by 4. That's going to give you this tick mark. This is going to be a pi over 4, and you're right. This is a pi over 4. So if we just find b how we did on the other problems, we would do 2 pi divided by pi over 4. And we had some practice on this before where you cross out the pi's. This is really 2 divided by 1/4, which is 8. Now let me just show you one other way to come up with 8. Remember that b? This number right here is actually frequency. It's how many cycles are there in a 2 pi span, horizontal span. So if there's 4 cycles for pi, how many would there be for 2 pi? 8. That's another way, maybe a little bit easier, that you could have come up with 8. But you didn't have to know that. Okay, let's put our x here. And again, with sine, it's kind of difficult to come up with the shift to the left or to the right. Okay, But at least this breaks up nicely with the fraction. So if I were to break up pi over 4, which is what the period is, and by 4, basically finding critical points. So if I were to say pi over 4 divided by 4, I wanted to know how far apart my critical points were. That would be pi over 16, which should make sense. So that's what each of these tick marks are, these littler ones. They're each pi over 16. So what would this one right here be? 3 pi over 16. And it should make sense that the fourth one would be 4 pi over 16, which is pi over 4. So I'm going to write minus 3 pi over 16. You could have made it a little bit easier on yourself if you had imagined what the graph would look like to the left, and you could have just written x plus pi over 16. That would have worked as well. Cosine's a little bit easier, usually is. 4 plus 9 cosine, still an 8 here. The reason cosine's easier is because there's no horizontal shift at all, and so you just write x, and you're done. Okay, this right here, I don't want to say this is as hard as they get, but this is pretty tricky. So if you feel pretty confident with this, then you're on the right track. Okay, look at number 5. What mode are we in? It's pretty obvious to me. Hopefully it is to you too. We see a degrees with 3 and with 23, and I see a theta. So I know that I'm dealing with degrees. Okay, the sinusoidal axis is not marked, so there's a couple of different ways you could do this. We know that it's halfway between 56 and negative 38, so I could find the distance between these two, divide by 2, and then either subtract or add, depending on which direction you want to go from. Or I could average out 56 and negative 38. Okay? Or some of you are pretty good with number sense, and you can just figure out what number is. Excuse me, sorry. Excuse me. So you could find the number between... Sorry. Excuse me. Okay, so let's average them out. So that would be 56 plus negative 38 divided by 2. So that would be 56 minus 38, which is 18. And 18 divided by 2 is 9. So that's a little 9 right there. That's our sinusoidal axis. Okay, and to find your amplitude, you could subtract 56 minus 9, or you could add 9 to 38, basically the positive 38. Either way, let's go ahead and start writing our equation. We get y equals 9. And the amplitude here would be 47. 56 minus 9 is 47. 9 plus 38 would also be 47. Okay, then we have our sine. All right, look your b value. Remember, you just need to find from peak to peak. Whether you're doing sine or cosine, it doesn't matter. Peak to peak is generally the easiest way to figure out what the period is. So from 3 degrees to 23 degrees, just subtract the 2, or just think about what is the distance between. So that's 20, so that's the period. So to find the b value, remember we're back in degrees now, so we want to do 360 divided by 20. That's going to give you 18, so our b value is 18. And then make sure you're using theta when you're dealing with degrees. And once again, with sine, it's kind of difficult to find this one. I'm going to let you try to do this one on your own. Okay, pause the video and keep trying if you need more time. Since our period here was 20, I think maybe using critical points would be easiest, because 20 divided by 4 is 5. So if I know this is right here at a 3, I don't really want to add 5 to get to this tick mark. That's not really helping me, because that's then a vertical reflection. I really want to find where it would be over here. So I want to subtract 5. That would put me right at -2. So for the sine, I could put +2 here. And there are other options you could have picked. All right, let's do cosine. 9 plus 47 cosine of 18. I really should put a degree mark there. Theta. This is a little bit easier because it's shift to the right 3 degrees, so -3 degrees. So let me just say this one more time. You can definitely incorporate vertical reflections into this. Usually that overcomplicates the problem, but it's not wrong if you wanted to do that. And all of these you can check on your calculator.